So today we're taking a look at solving exponential equations that look like this. Now first of all, notice this is 8 to the power of x equals 80. No, I cannot just divide both sides by 8. Because if you divide it by 8, well, what's 8 to the x divided by 8? I don't know, like 8 to the x minus 1, something like that. So we don't need to do that. We need some way to solve for the exponent. Well, we actually have a way, right? That's why logs exist, yes. And so step 1 of solving for this then is turn it into a logarithm. So we start by writing it as x equals log base 8 of 80. This is just using the same logarithm rules that we had from before, where I know it's going to be log, and the base is whatever's raised to the power. Whatever's by itself over here is the big number inside the logarithm. Log always equals the exponent, all that kind of stuff. Now that I've done that, I can calculate this value. And so now you break out your calculator, because that's not a nice, easy number there. It's not one we can just do in our head. And we calculate it. Now, in order to calculate this, though, what do we need to use? What do we call that? We don't remember the name, but we remember the process, I can tell. It's called change of base formula. That's the one where we do the log divided by log. Specifically, remember that the base always goes on the bottom. And so we're going to calculate log of 80 divided by log of 8. And then when you do that calculation, you should be getting an answer of about 2.11. Notice I said to round to the nearest hundredth. So yes, this is the number I should be looking at on your paper there, 2.11. If you can do that last problem, then you can do this one. Because the basic method is following the same kind of stuff you already know from your algebra work. The only hint that I probably need to give you here at the start of this one is that your first goal is to get the exponential part by itself. So that's whatever is raised to the power of x. And you notice the minus 1 is up in the exponent with x, so it goes with it. So basically I'm trying to get that by itself first. So get rid of the 2, get rid of the 8, and then you can deal with that part. Now that we've gotten rid of the 8 and the 2, I'm now down to just the exponential part. So I got some number that's raised to the power of something involving x. Just here it has an x minus 1. But we still are going to transition into a logarithm from here. And we're still going to follow the same rules that we would normally follow from here as well. And so when we go from here then, remember that log always equals the exponent. And so my log is going to be equal to the exponent. The whole exponent is the x minus 1, so it all just goes as one piece. And then the log part works just the same as before. The base is going to be 3, and so it's going to be log base 3 of 64. Now that we've gotten to this point, we can go ahead and just keep solving from here, because log base 3 of 64 is just some decimal that you'll be able to calculate, and we'll be able to get the x by itself, notice, by adding 1. So go ahead and finish it out from here.